we're going to rotate the region bounded by y equals log x, y equals 1, y equals 2, and x equals 0, which is the y-axis. And this region will be rotated about the y-axis, and we want to find the volume. So to start with, first thing is let's get a sketch of what that looks like. We have y equals log x. So we have y equals 1 is horizontal, and then we've got y equals 2, another horizontal, and then x equals 0 is the y-axis. So the region we're looking at is bounded by log x, y equals 1, y equals 2, I should have done that a little better, and then x equals 0. We're talking about this region here. This region now will be rotated about the y-axis. Because I know it's the y-axis, I'm going to subdivide from 1 to 2 into n subintervals, and here is a typical rectangle. And this rectangle will determine, this rectangle, when rotated, will determine the disk. About the y-axis, volume will be this, the integral from c to d pi f of y, which means the x value squared, dy. And our radius, we can see, is going to be the x value on the curve y equals log x. But y is log x. In order for me to have the x value, I have to solve for x. That involves taking both to the base e, and I get that x is e to the y. So another way of saying y equals log x, I can also write it as x equals e to the y. Alright, so now what we get is we get that the volume is the integral from c to d, from 1 to 2, pi e to the y, that's our x, e to the y squared dy. And using our rules of exponents, this is pi e to the 2y dy. And this integral is going to involve a u substitution. Now to work this, I'll do a u substitution. U is 2y. 1/2 du is dy. So this just becomes pi 1/2 e to the u du, which is pi over 2 e to the u, which now I can replace u. And this becomes pi over 2 e to the 2y, that's our u, from 1 to 2. Working this just becomes pi over 2 e to the 2 times 2, 4, minus e to the 2 times 1, 2. And that's our answer. So that's the volume of that particular solid.